Your challenge today was to find the pressure in a 2-liter bottle after at least 300 pumps of air. Here's what was given. I'm going to do my work off to the side. Let's start by identifying all the variables at the initial conditions. Pressure was given to you according to my pressure app. According to my weather app, the pressure at the time this morning was 765 millimeters of mercury. But we need to convert that to either atmospheres or kilopascals. I'm going to do that to atmospheres. I'm going to need a calculator. Somebody left a calculator this morning. If this is yours, I'm going to borrow it and I'll put it right back where you left it. I'll store that number, 1.01. Let's go with that. P1, initial pressure. The volume, told you to use 2.00. It's kind of ridiculous. How do we, like, it's all crumpled up. We're gonna go with that. And that's going to be our initial and final volume because the volume of the 2-liter bottle is not going to change. R is the universal gas constant with atmospheres and temperature. You've got to read the thermometer between the blue and the brown, or the green if you see the green. So the temperature in this room right now is 21 degrees Celsius. So we need to add 273 to that to turn that into Kelvin. And that's going to be our initial temperature. All right, let's stick this guy in here. So in this bottle right now, the pressure is 1.01 atmospheres. It's 2 liters, and the temperature is 294 Kelvin. Oh, we need to get the number of moles. Pressures. Volumes. I'm going to use my stored number. That's my pressure times the volume divided by R divided by temperature. .0834. All right. Now let's pump some air. I'm going to do at least 300, if not 1,000. See how far I can get. Press. Whoop. Oh. Keep on it. Looks like we're at 24. All right. Might run out of room, but let's see how it goes. T2 is 24. T2 is 24 degrees. Let's add 273 to that. And we're going to get 297 Kelvin. Knock my little friend over. What else do we need? The volume hasn't changed, so I'll stick that back in there. V2, still a 2-liter bottle. And we need temperature too. Oh, we just got that, sorry. Wait, volume, oh, number of moles. So we need to find N2. We can do that. Use the scale. Let it calibrate. Pop this guy on there. Want to zero that out once it stabilizes. Okay. Now that we zeroed it out, I'm going to let the air out. Let the air out now. Now the pressure is back to room pressure or atmospheric. Now the pressure is back to normal. And wow, that bottle feels cold. So we'll get to how this relates to weather maybe after your exam and sometime in the future. All right, so we have negative 2.89. So that 2.89 grams represents the amount of air that I pumped in there. Let's do that off to the side. So 2.89 grams of air. We want to convert that to moles. We're given the molar mass of air right over here, 2896. Borrow my friend's calculator again. That's the mass from my scale. That's the molar mass of air. That's the gas in our room. 0.099, all right, 0.1. Now, that's not the amount of air in our bottle. That's the amount of air I pumped in. There's still air in our bottle. This is the air in bottle. This here, air pumped, added air pumped. So we need to combine them. That's what I'm trying to say. Let me use these stored numbers again. So we're going to add that. We're going to add that to, there it is. So there's the total number of moles, 0.183. All right, now we can plug and play one more time and solve for the final pressure, which was the challenge. That's an awful looking R. My hands are shaking. Volume. Right. That guy goes right there. R is the constant with atmospheres in it. Whew. And T, second temperature. I expected the temperature to go up more. I guess I didn't pump enough air in there, I guess. 297. I think you all got something higher than that. And the volume is still 2 liters. All right. Moles are gone. Kelvins are gone. Liters are gone. We'll have our final answer in atmospheres. Okay. One more time. Number's still there. Times that by R. Times our final temperature. Divided by the volume. 2.23 atmospheres. Did you get close? Now, if you want to convert that to kilopascals, we can do that. $226. Wow, some of you got it. 226. Huh. I remember seeing that from somebody. Good for you. Now, of course, your number might be slightly different based off of how many pumps you got in, more or less. Honestly, I pumped for like 3 minutes. My hands were getting tired, so I probably got in like 200 pumps.